So lesson 4 is what we did today, exploring exponential decay. By the end of the lesson, and I know some of you haven't had it yet, but when you have it, you should be able to use only multiplication to represent decreasing a quantity by a fraction of itself. Talk about that with some examples shortly. Then be able to write an expression or equation to represent a quantity that decays exponentially. So there's exponential growth and exponential decay. Based on the names of them, which one sounds like it's increasing over time? The growth, good, thank you. So exponential growth increases, and exponential means like at a really fast rate. So increasing exponentially, that'd be your growth. That means exponential decay decreases over time. Prior to this lesson, it's just been looking at growth. Now incorporating decay. So it's really similar, except for there's this one piece that will make students sometimes write the wrong equation. That's why today in the lesson, I had you review both of the equations that can represent decay. If you've not had the lesson yet, you may want to write this down. Or even if you did have it already, you may want to write it down just because this is something you're going to have to remember. So my exponential functions, just in general. Table 9, can you tell me what the formula is for just exponentials in general? Y equals, that's mx plus b is linear. Oh, okay. Exponential is our unit that we're doing right now. A, B, and then usually we use X, but yeah, X can be T because X is usually time anyway. So they helped you out with that. You're welcome. Table 9, can you tell me the one that's specific for decay? Everyone else needs to stop having. Okay, so your growth rate or decay rate, I guess, if it's decay as a decimal, what else would need to be in it? In the formula? A for sure. B is the 1 minus R or 1 plus R if it's growth. So that stays the same, and then it's also having an exponent. That's what makes it an exponential function. So if you compare this to the one we learned on Friday, compare it to the growth one, what's the only thing that's different? Table 5, can you tell me that? So look at my decay formula. My growth formula is almost identical except for what? So look at the decay formula. My growth formula is almost identical to this except for what? What is the only thing that's different from decay growth? We'll let table 5 do it. Nope, that will still be the same. Damien?
The subtraction sign, it'll be addition of that.
Okay, good. So for growth, it's almost exactly the same, except for we're adding the rate each time instead of subtracting it. So if you really understood Friday's lesson, now it's just decreasing over time. So just make that adjustment. We'll do an example or two shortly. Now, the only thing that seems to confuse students to where they give the wrong equation is, say that we are losing 20% of the value each year. All right, what's 20% as a decimal? 0.2, thank you. Now, here's the problem that students will run into. They'll make their equation and it'll be, I don't know, whatever A is times 0.2 to the T power. What's wrong with that? Well, yeah, pretend A is there. Why is my parentheses not gonna be 0.2? If I'm losing 20% each time? I didn't put it in correctly. What should it be? No, that's not what's wrong with it. If I put 0.20, it's still the same. So look at my formulas. I'm not gonna be multiplying by 0.2 each time to get the next number in the pattern. I'm gonna be multiplying by what? Anyone, I don't wanna give it away. 'Cause that's the common mistake that we see on tests. We will usually include, if this was multiple choice, an answer that looks like this to confuse you. The 1 is missing. It would be 1 minus 0.20, which is what? Class. Calculator, like doesn't get any easier. If that's hard, then sorry. 0.8, good. So what it should actually be is it could either show this part, sometimes it does, or in the parentheses, they'll already have it simplified. So instead of timesing by 0.2 each time, you're timesing by 0.8 each time. So not by what it's losing, by what's remaining, I guess you could say. That's the part that was like the main point of the lesson today. That's why we bothered doing the two different things, where it's 1 minus, or just times what remains, okay? So keep that in mind when you get to that lesson, if you haven't yet today. That might help you out with some of the notes, but that's the gist of it. So when in doubt, maybe use this one, other than that one, that's like our general equation. So let's do at least one example before I cut you loose to try the practice. Here's one example for those that haven't yet had the lesson, or maybe that already had it and may just still need another example. So let's look at number 7. It's only on the screen. If you want to take notes, you can. Not forcing you to. It's up to you if you want the additional. So the population of a town is decreasing at a rate of 1% per year. In 2000, there were 1,300 people. Use an exponential function to find the population in 2008. Here's that formula again. That is specific to Decay, or you can use the one that is just very general that works for both. What does A stand for again? Table 7? My A in the equation stands for what? Table 7, you'll tell me A. Table 2, what about R? Table 2, you have R. Table 3, what about T? Time. So in this, since T was the only one we could identify right away, how much time has passed from where we started to where they want us to figure out? 8 years has passed from 2000 to 2008. Table 7, did we figure out what A stands for? Okay, good. What is my initial amount? In numbers of different. Okay, they helped you out 1,300. Cause they wanna know what's my population after this many years. So what did you start with? 1,300 people. Then it's 1 minus whatever the rate is, but the rate has to be a decimal. Sorry, I took that answer away from you. What is it decreasing by, table 2? %, and what's 1% as a decimal class? 0.01, and if you don't know that conversion, divide by 100%, now you have the decimal. Now, all of this you can put in your calculator. Please use a calculator. Maybe not the y equals part, but everything else. So that was. Sorry, taking a long time to read. That was 1,300 times 1 minus 0.01, which on your test, it might already do that math. Or it might show the 1 minus 0.01, that equals 0.99. And then that's to the 8th power. This is the answer I get. Now, if this was on my homework, we're talking about people. What number should I enter into the box if we're talking about people? So not the decimal part. And even though, so if this was a question on my homework, I would just type in this, nothing else. Even though normal rounding rules, you probably normally round up. Not for these. Okay, just cut it off at the decimal. It doesn't support having a whole nother person, just 0.56 of a person, which you can't have. So you just stop at the decimal for that one. If it was money, what would we round to? Good, the hundredths, and if you don't know what that is, that's 2 decimal spots, if it was money, but this one's people. So there's that, I'll leave the example up just as a reference. If you haven't had the lesson yet, please still try the practice, but if you need help, let me know. What else? I think that's it. 80% or higher is the goal. Once you've met that goal and you want to free time, by all means, but that needs to be done first. Otherwise, like maybe this isn't the place for you. John? Yes, you can listen to music while. The first request is for number 3 on the practice, the one about a computer costs $800 and loses 1/4 of its value every year after its purchase. We're making an equation representing the value V of the computer T years after its purchase, and it tells you how to enter exponents so that it scores it correctly. So let's use the setup from the 2 equations I said could help you. And since it's losing value, it could be either one of these 2 equations. And notice it says only parentheses for multiplication. So don't have it with the 1 minus. I don't think it'll accept that. Have it to where it's just multiplication for this part. Anyway, what's my A going to be in this one? 800, because that's my initial amount. 1 minus R, so what is the rate that it's losing? So what is 1 minus 1/4? You can tell me the fraction or the decimal. Okay, 0.75 or 3/4, same difference. I think it should accept both. But we'll just see. And then for the exponent, you need to use this symbol, like how it shows you right here, or it gives you instructions right here. Use a slash for fractions and use this symbol for exponents. So shift 6 is where you find that symbol. And what should the exponent be in this one? Does it ask me over a specific year? So it should just be T. Let me see all the different ways you could enter it. Because sometimes it doesn't have all the ways and I need to add it, so give me 1 second. Okay, so the way that I typed it like this should work. Don't put any extra spaces or things like that. Let's see if it also accepts 0.75. Okay, it looks like it doesn't, so I might need to add that. Let's see if without the 0 it works. Nope, so I need to add that because that is still correct. So you could type it like this or with the other slash. But I'll add it so that it does 0.75. Normally when it's fractions, they want you to use the fraction instead of the decimal. But if it's a decimal that ends, you can use the decimal. That's fine. I might need to add that to everyone else's, so. Yeah, questions though on that one? Yes. All right, we had another request for number 4. So again, if you want to continue working by yourself and quietly, that's fine. But if you needed help with number 4, it's on the screen. So same situation. We're using the equation we already created. So let me copy that down. Okay. Unless you're answering a question I'm asking you. You're welcome to work by yourself, so you're fine. But it says, use the equation from the previous question to find V when T is 5. So we're gonna make that T 5. And you need a calculator. There's no way around it anymore. Oops, that's not what I wanted. Should be 3/4. And it's gonna be to the 5th power. So if you're having a calculator that you have to put it in one part at a time, make sure you do exponents before multiplying. That's order of operations. Or invest in a calculator, like for your state testing, that you can type it all in at once. For the exponent button, you can use this, or like the shift 6, and it'll automatically do that for you. It wants it for 5, like over 5 years. So if this is what it says, let me see if it wants me to round anywhere specific. It says 100th. So how many decimal places is 100th place? 2 decimals. So that means wherever you need to round to, look to the right of that number. If the number to the right is 0 through 4, it stays the same. If it's 5 through 9, you round up 1. So should it be 189.84 or 189.85? Okay, good. That's what you should type in. Let me make sure the key is right. And that is correct. So the equation lets you solve for any exponent, basically any time frame that it wants. That's why it's better to know how to make the equation. Questions on this one? The bicycle one, yes. The one that says a new bicycle? Okay. So a new bicycle sells for $300. It is on sale for 1/4 of the regular price. Select all the expressions that represent the sale price of the bicycle in dollars. So one thing I would probably do as well is figure out what the sale price is so that I can verify all these answers. Because it's a select all, you have to check them all. So if it's on sale for 1/4 of the regular price, This is where I said, like, this has saved me a step in the real world. Instead of doing 300 times 1/4 and then subtracting it from 300, what could I just multiply it by? So I mean, you're not wrong, but that's like 2 extra steps. If I do this initially, then I just do 1 step. Multiply it by 3/4, by what it's keeping, essentially. That'll save you the step. Or you can just do it the longer way, as long as you get to the right answer in the end. So it's keeping 3/4 of the price. So that's 300 times 3 divided by 4. It's on sale for $225. So let's see if this one has what I already have, which is like right there. And then see if any of the others will also give me this answer. So does timesing it by 1/4 give me the sale price? Okay, we got 1 vote for no. Okay, you're correct. It gives me the discount value, not the sale price. The sale price would be the 225. So don't pick this one, that says times 1/4. Would this one that my mouse is on give me the sale price? Yes, because 1 minus 1/4 is 3/4. So that should still give me the sale price of 225. Does 300 minus 1/4 give me the answer? Definitely not. What about this one? Yes, because that's like the longer way that I used to do my math in the store. I used to figure out what 1/4 times 300 was, which I don't know what that is. 300 divided by 4. All right, it's 75. But then you still have to subtract it from the original price, which then gives you the 225. This way is easier. Figure out what it's keeping of its value, times it by that instead. But let's see if we selected all the correct answers, and we did. So it should be these 3. Might be shuffled on yours, so make sure you pay attention. But yeah. Right. Any others? You don't have to ask more questions, but you can if you want to. Know that, like, say you didn't get the full points, maybe you got 80% or higher over the weekend or something for something already graded. I do kind of spot check, but after like so much time has passed, like I won't. If you want the points updated and you want to make sure they get updated, take a screenshot of your new score, put it in the assignment link in Math Lab, and I'll make sure it gets updated. But I'll just like spot check until, I don't know, at least a few days, maybe a week, but usually no more than that. Good so far, any questions? Okay, try not to line up or anything until 12:04, but if you didn't meet the 80% threshold, definitely make sure you do that, whether it's in here, whether it's later. That's the points for Math Lab.